It might be another section that it happened in. Couldn't tell you.
We'll figure it out eventually.
Yeah, later in the year it might happen again, so just fair warning. Okay, so these ones said to convert to inequality notation, find the endpoints and state whether the interval is bounded or unbounded and its type. So we have -3, -1, and it's parentheses. So in inequality notation, what would this be?
-3 less than x less than -1.
Yep. And then what are my endpoints?
-3 and -1.
And then are we bounded or unbounded? And is it open or closed? Bounded and open. How about 32? We got a bracket, -6 to infinity. What is inequality notation for this one?
-6 is less than or equal to x.
Yeah, I'm going to write it this way because I like this variable on the left, but yes, same thing. Endpoints.
-6.
Yep, not infinity because that just keeps going. Endpoint would have to have a stopping point. Bounded or unbounded?
Unbounded.
Unbounded because of the infinity. And open or closed? Closed. And don't forget with the ones like this one, you do have the option of it being half open as well, if it was a bracket and a parentheses. But if it has the infinity, then it's just whatever the other symbol is. Use the distributive property to write the factored form or the expanded form of the given expression. So basically, whatever it does, you're doing the opposite. So 38, we've got y minus z cubed times c. So basically, in this case, it's already like basically condensed down, so we're going to expand it. If it's already expanded, we're condensing it. So what are we doing for this one?
I'm going to distribute the c.
So we get cy minus cz cubed. If you were to write the c after, that's obviously also fine, but I look at c as a number and y and z as variables, so that's why I put the c in front.
I think we should do it in alphabetical order.
Well,
It
yeah,
just
that too.
better.
I agree. All right, and then 40, if we have a cubed z plus a cubed w. So that one is already expanded. We need to condense it down into factored form. So what would we do with that?
A cubed outside of parentheses and then z plus w inside.
Yep.
So that one we just pull out whenever we can, right? That's
Yep.
Okay.
Yeah, so it's like factoring out the greatest common factor, basically.
Okay.
Also, I don't really know if you've like looked through the book too much, but there's only like in each of these like little topics, you're probably like, she's only doing like 2 problems. Well, that's like all the even problems in those sections that there are. They only do like 4 of each type, sometimes like 6. So that's why there's like not as many. So just so that you're aware. I'm not just like, oh, they're good. I mean, I think so far y'all are good, but like we may get to times when that's all the examples that there are and you're like, I'm still confused.
Gotta make up some.
So, yeah, that's not always the best thing. Making up problems is like not my strong suit. I'm like, I need the book to like, that's why the Algebra 2 book is nice, even like Algebra 1, because there's like a whole section of like extra problems at the front that you can like go pull from. This book doesn't have that. I'm like college algebra, I don't even have teacher edition. So like, I'm working just with whatever y'all have kind of thing. Like, This one is a teacher edition, but it's super annoying because only like some of the answers are actually in the text. Some of them are in the back. But I guess at least I have them because college algebra I don't.
I hated those questions on test where it was like, make your own like equation with these numbers. I was like, I don't know.
Yeah, I don't mind like the ones that give you some information, but when I'm like literally just starting from scratch,
Exactly.
there's no hope. Like it's just not happening. Did you have a question?
No, I don't think so.
Okay, I thought you had your hand up. At some point. All right, so simplify the expression. Assume that all variables in the denominator are non-zero. So 48. Parentheses, 3x squared, close parentheses, squared. So that's the whole thing getting squared. Y to the fourth over 3y squared. Any suggestions about what to do first?
We should square the 3x squared.
Okay, so what does that give me?
9x to the fourth.
Yep. And y to the fourth over 3y squared. And then what?
So,
Can you subtract the y's?
can we like divide, and then like can we divide the thing by 3?
Yep, so 9 will get divided by 3, so that's going to leave me with 3. There's no x's on the bottom, so obviously that's just getting copied over. Now, Virginia said subtract, so yes, that is what we're technically doing, is when we move the y's up to the top, we're subtracting it. We're basically not putting it where it ain't making it positive, but we're putting it where it ain't changing the sign. So that we're subtracting it down so that we'll end up with y squared. The other thing, if you want to think about it, since it has the same base, you can kind of just be like, well, 2 and 4, that just reduces to 2 if you wanted to think about it that way. The technical way to think about it is the subtraction way, but it's kind of just like you're at the point now where, like, if you just see it, you just see it.
Yeah.
I mean, it doesn't, you know.
Kinda go.
So now, if it was like 5 and 3, obviously that doesn't just reduce, you're going to have to subtract, but in this case, it kind of just reduces nicely, so it works out. 52. 4a cubed b over a squared b cubed, close parentheses, times 3b squared over 2a squared b to the fourth.
A lot.
So you want us to like, oh, you want us to do this one on our own?
No, I was just giving you time to copy it.
Oh.
I was getting my coffee.
Oh.
I decided to actually have caffeine today.
That's good. Make the good day.
And I'm not picking our volleyball jerseys up till like 9 o'clock tonight in Gloucester, so
So they are ready tonight?
they will be. She has to wait for vinyl to come in, and I have Julia's jersey here because it was in Hannah's box, so I have to wait and take that one. But so she's gonna press the last 2 tonight when I get there.
Yeah.
Well, I guess one she's gonna press tonight, and then she's doing all the jerseys, but only the ones that we need like desperately
Yeah.
for today or like this weekend.
Yeah.
So I'm gonna have to get Emma another Libera jersey for today because
I guess we'll just have to use the gray ones.
yeah, I was like, so I asked her, I said, if I don't have your number, I said, what size do you want? And I'm just gonna pull a number that we aren't currently using because I already had 10 out from last year because it was in Peyton's bag of stuff. I
Yeah.
just kept it together under the assumption she was probably gonna be Libera this year, and obviously that's changed. So I was like, I'm probably just gonna have Peyton keep that one though, because if we get to like a Stonebridge or something and we need to make adjustments, then we will. But yeah, I told Emma, I was like, you're just gonna keep the gray one after this because if something weird happens or the refs like have a conniption about it, then you at least have that one. That's fine. She's like, okay, that's fine. So I have to go pull those either like
Good time.
next period or at the end of the day. So, all right, suggestions on. Oh, nope, come back. Okay, I was like, don't go off on me. All right, suggestions on where to start with this.
So we could move A to the top for the first fraction and then B to the bottom.
I would not do that initially.
Oh, so
Multiply it all.
I would get one thing first, and then I would do that. So I would basically add across the top and the bottom, like the exponents. Now, Somebody said something about crossing. Were you talking about the 2 and the 4? I don't know which one of you said it.
I don't know what I was talking about.
Okay. So I could go ahead and say, like, okay, 2 and 4, that's going to reduce down and leave me with a 2. But then I would go over here and rewrite this all as, like, 1. So on top, what does that leave me with?
2a cubed. No, sorry. 6a cubed.
B cubed.
And then on the bottom?
A to the 4th, B to the 7th.
Okay. So then now I can simplify it down. The whole reason I didn't want to do it originally is because, as you can see now, anything that got moved to the top is going to end up being negative and have to get moved back. So I like to combine as is initially, and then I'll go through and I'll cancel at the end. So what does this leave me with then?
6 over A, B to the 4th.
Yep. Questions about those
Oh,
or anything? It's like the basic stuff that kills you usually, so.
just think I was like, how
I did math.
Okay.
Really simple.
These next ones are scientific notation.
Oh, yay.
Okay. Write the number in scientific notation. So the problem says something like the electric charge in coulombs of an electron is about, and then it gives you a number. I'm not going to write the whole problem. I'm just going to write the number.
Cool.
It's negative 0. 18 zeros.
Okay. The whole thing's just zeros.
And then 1 6.
How many zeros again?
18. After the decimal point.
Okay.
If you count the one before, it's 19.
Oh, 1 6.
Yeah,
I
when
thought you meant like there's
1
1 6.
I mean, there is.
1 then a 6. Like, oh, I got plenty of room. No, we don't.
Okay, so what is this number in scientific notation?
Negative 1.6 times 10 to the 7th. No, 19.
Negative.
Negative 19.
Wow, I'm so smart. That was close enough.
Oh, no, no, no.
We all.
You did
Oh,
exactly.
what happened? My decimal point disappeared.
It's like, what do you mean? What happened? No.
I was like getting ready to like make the circle better, and then all of a sudden it was gone. I was like, oh.
So if we're moving the decimal point to the right, then it's negative, or
Well, yes, because the number originally was a little tiny decimal, technically.
so if it's getting bigger, then it's negative, pretty much. Like if the number in scientific notation will be
Basically, yes.
okay.
In general, when you get back to here, negative means moving left. So the decimal to get back to the original number would have been moving left. And if you got down to like whatever so like you could do this and you could be like, well, if I move it right, it's going positive. Oh, that's a really big number. So you would know you need to move it left, and that way it's negative. That's the easiest way to think about it. But decimals, like super small decimals, should always end up negative in scientific notation. And super big numbers should always be positive. You look confused.
And I am. Do you mean super big numbers by like literally
Like millions. Like
Okay.
having lots of numbers.
Okay. So like, but when we're condensing, like
This is technically a super small number because it's a really small
Yeah.
decimal.
then, so we're technically making this bigger. Then it's.
I mean, it's looking like it's
Yeah.
making it bigger. Yes.
Yeah.
Obviously, the number is staying the same.
Okay,
We're just
but-
writing it differently. Yes, it looks bigger
Okay.
in this way. The other way, it looks smaller because
Yeah.
you're taking off all the zeros usually.
So
Okay.
it makes the numbers less intimidating.
Basically, yes. Sure.
Saves me space in here.
All right, 60. So the opposite, 6.7. Whoa. 6.73 times 10 to the 11th. So this one, they already give it to you. Oh, this is a different. This says to write it in decimal form. Sorry, there was only 2 problems in that section. So this one, we're doing the opposite, and so we need to move the decimal point. Which direction?
Left.
Right.
Right, it's positive.
Oh. Oh.
You're funny, Liz.
Okay.
So 6, 7, 3, so that's 1, 2, so then the rest is zeros. 3, 4, 5, 6, 7, 8, 9, 10, 11.
That's just like 673 billion.
It's a lot.
That's all. I mean, when you have the potential to count up to a number like duotrigintillion,
You see that
billion
a lot.
sounds kind of small.
Yeah, that's
Also,
Too
it'd be
much.
impossible to count up to a number that big in a lifetime.
yeah.
But try to do it.
No.
Give me 10 minutes.
No, I'll give you 10,000 years.
1, 2, skip a few.
Exactly.
Probably don't even know how to
I don't
pronounce
know what
it.
the word is.
Okay, the last one say to use scientific notation to simplify. So I think we may have done a couple of these problems last year, but we didn't spend a ton of time on it. So if we have something like 3.7 times 10 to the negative 7, my eraser popped up and I was like, why is it not writing? Times 4.3 times 10 to the 6th divided by 2.5 times 10 to the 7th. This is not a, let me just get my calculator out and multiply this real quick. This is a rewrite the numbers, okay? So it would be something like 3.7 times 4.3 over 2.5 times 10 to the, and then this is where we can kind of combine the exponents. So on top, we're adding them together, so that leaves me with a negative 1, and then I have 7 on the bottom. Remember, scientific notation is the only exception to us having negative exponents. So we want it to be on top, not on the bottom. So I would subtract 7, so that would end up giving me negative 8. Okay, do you see that? So I did negative 7 plus 6, which was negative 1, and then minus 7, which is the negative 8. And then I would, at this point, yeah, I would get a calculator and multiply those. I mean, you can do it by hand, but, you know, it ends up being 6.4 times 10 to the negative 8. Any questions about any of that? Okay. So your problems for this section.
Oh, wow,
It's so long, that math,
All right, 1 through 21, every other odd. 29, 37, 39, 47, 51, 57, 61, and 63. And I'm sure you're like, that seems like a lot. But part of that is just because there's such a wide variety of stuff in this section. Don't expect that like every section of homework is going to be like that. These just, like this section just covered a lot of material.
Probably like a bunch of like short, easy problems.
I hope so. I'm sure. Exactly. Wasn't all we like 5 steps each?